Welcome everyone. The aim of this session is to help you with the first assignment for this module, which is to produce a scientific paper. The suggestions and advice given in the presentation have been extracted from the assessment brief for the assignment. This first part of the recording will focus on three aspects of a typical scientific paper, which is the abstract, the introduction, and the method section. And results and discussions and conclusion and appendices will be covered in the second part of the recording. The aim of an abstract is to showcase your paper, to showcase your research to your fellow scientists, to your readers. Writing good abstracts is a skill worth developing. Most people will judge your paper or your report, if you are working for a company, on the basis of its abstract. In a company report, the abstract is normally called executive summary. A typical recipe to write a good abstract is as follows. Ideally, start with a sentence or two outlining the importance of the research area in which the experiment sits. The idea is to grab the reader's attention, to highlight how important that particular field is. So why is it important to research in water quality? Why it is important to look at the water quality in marshes? Why are partition coefficients important? Some sort of general sentence or two that will really focus your reader's attention, and they will really send a message. This is a really worthwhile field to research on. This is a really worthwhile paper to read. Then typically you would mention the purpose of the experiment, the aim of the research, and literally your readers will expect something like the aim of this research was to, and that's where you include the aim of the experiment. It's also important to give a brief indication of what the experiment actually entailed. It's not the place, the abstract is not the place to write a long-winded explanation of what you actually did in the lab, but it's worth including one or two sentences in that you give a brief indication of what you actually did. Potassium and sodium ions in bottled water were analyzed using a flame photometer, or the partition coefficient of salicylic acid in dichloromethane and water was measured using the shake flask method. That will help your reader decide if the methods you have used are meaningful to them. If they are looking, for example, on papers that use flame photometers, and you have used one flame photometer, it might be that the experiment itself is not interesting to them, but they are interested in the technique you have used. Finally, include a couple of sentences in which you highlight one or more key results, maybe a brief indication of what they mean. A research paper is not a mystery novel. Your reader don't want to wait until the end to find out who did it, to find out what was your key result. They will expect you to write that key message, that key result already in the abstract. So, and some indication of what that finding actually means. For example, the partition coefficient of salicylic acid in the chloromethane water was X, and that compares well with literature values for this compound, or does not compare well with literature values for this compound. It doesn't matter what you conclude, but it's worth highlighting to your reader already at this early stage what's going to be the main message of your experiment. Abstracts very rarely, for not to say never, contain references. And that is because they are often written, they will be often extracted from the paper and put into a database. Think of Google Scholar or our own library research database service. So they cannot have a link to anything else. They need to be self-contained. So avoid including references in the abstract. My suggestion would be that before writing abstract, you write the whole paper. So once you have decided what you're going to include in the paper and your draft is written, then you can extract one or two key sentences of the introduction, one or two key sentences of the methods, and or two key sentences of the results and discussion, and put them together and make your abstract that way. And that will be an abstract that will reflect really well what is actually in the paper. The introduction is to cover key background information in which you highlight the importance of the particular research area that your experiment sits in. The introduction has like two purposes. On one hand, you are trying to teach your reader everything they need to know to understand your paper. And when you think about your readers, do not think of people that don't know anything. Your readers for a scientific paper will be other scientists. There's no need to start with very, very basic definitions that you would assume typical scientists would already know. But you do have to give them some key information about what that particular research area. For example, the importance of water analysis, or how flame photometry can be used to measure metal ions. Another purpose of the introduction is to establish your voice as an expert. You want your readers to trust what you're going to tell them in the results and discussion, your conclusions about the research. And to establish that your voice as an expert, to establish to your readers that you know what you're talking about, you do that work in the introduction. You're showing them that you are aware of the key references, up-to-date research references related to your chosen practical. So engaging with primary resources, engaging with research papers, especially recent ones, is important. I typically suggest for the scientific papers I set as an assignment that students can choose whichever angle they want for their introduction. And what I mean with that is, for example, choosing a practical which is determination of potassium ion and sodium ions in bottled water using flame photometry. You could write a fantastic introduction talking about water analysis and the importance to analyze water, bottled water, or the importance of analyzing potassium and sodium ions in bottled water. On the other hand, you could write an excellent introduction talking about how useful flame photometry is as an analytical technique, and how it is widely used in research to analyze all sorts of chemicals. That would be a completely different introduction in which the focus of the introduction would be the technique rather than what you did. And they're both equally valid. Just try not to tackle both things at the same time. Just choose one angle, one aspect that interests you in the experiments you have conducted, and talk about it. And that gives a more coherent structured introduction. You don't want your introduction to look like the kitchen sink, in which you're chucking some information about marshes, some information about pH, some information about phosphates and nitrates. So think carefully what information you are going to include in your introduction. And you might want to, the choice of what to include is whatever you find more interesting, but you might also be limited by the type of references you can find. So my suggestion is any angle that allows you to engage with research papers, and especially recent research papers, is always preferable. Avoid all references unless they are really key to, they are a paper that really your reader cannot live without you mentioning it. All references send a message to your readers that what you did is old, boring, old, and nobody cares about it. The introduction must always contain in-text citations. It's not enough to mention references and reference lists. The readers need to be able to trace back at every given time throughout the introduction where that particular piece of information comes from. And you can only do that if you use syntax citations. Finally, at the end of the introduction, include the aim of the research. That's where you normally would put it in a research paper. And something as simple as the aim of this research was, and that is a cue to your reader that the introduction has finished and now the method section is coming. The method section is a brief summary of what was done in the lab using past and passive. The use of past and passive might not be that common in other fields, but it's definitely used in chemistry papers, such as this one. 0.2 grams of salicylic acid were measured. A flame photometer was used. The samples were heated. Past and passive and third person. It is not copying and pasting the practical handbook. The handbooks are typically written in imperative: weigh 0.2 grams, use the flame photometer, filter, because they are giving you instructions for you to follow. The method section on a paper is recalling what was done. So that's what is used in passive, and third person, because it's a more formal way of writing, and it's a typical way of writing chemistry papers, methods section for chemistry papers. Do not give excessive detail. If there's a titration, there's no need to explain how a titration is performed. Simply say solution X was titrated using chemical Y. If you're using the flame photometer, you don't need to explain how the flame photometer works, or how a UV visible spectrometer works, or how a pH meter works. Simply say a flame photometer was used to measure potassium ions and sodium ions. A pH meter was used to measure pH. That is because the method section of a paper is not the place to learn how to use a piece of equipment, or it's not the place to learn how to perform a particular experiment, a titration, for example. If your readers want to know, your readers either already know how to do that, or if they don't know, they need to go to a technical manual to learn it, or to a teaching manual, or to a laboratory manual. It will not be the method section of a paper that teaches them how to use a piece of equipment or how to perform a particular experiment. So keep that in mind when you are writing your method section. And as usual, if you have any questions, please drop me an email. So with this, I've finished the first part of this presentation. And in the second part, I will start from here and talk about the results, discussion, and conclusion sections of your paper. Thank you for listening.